Today on Radio Boat Anchor, I'm going to restore this vintage 1966 TEAC A1500W reel-to-reel tape recorder. My wife found this vintage reel-to-reel tape recorder for $35 at a local garage sale and thought it would be a great addition to my audio collection. Physically, it looked great. Knowing how old it was, I knew it would need a complete restoration. Included was a clear plexiglass cover. The previous owner included a tape of what I assume was vintage rock music. Initial testing. Initial testing indicated several problems. Both reel motors were working, but the pinch roller would not engage. In addition, the reel brakes should immediately stop the reels from moving when the stop button is pressed. There is some coasting after the stop button was pressed. Chassis removal and cleaning. It is important that the 1966 TEAC A1500W reel-to-reel tape recorder is disconnected from power during servicing. The easiest way is to remove the power cord. The chassis must be removed from the wooden case before it can be serviced. The first step was to remove the tape and take up reels. Once vertical, 8 screws were removed, in order to remove the back cover. Do not make the mistake I made. The screws on the left and the right side of the wooden case do not need to be removed. Only the top exterior screws were removed for chassis removal. The brushed aluminum front cover was then removed so the chassis could be removed from the wooden case. Several external parts were removed first. A single screw was removed in order to remove the tape head cover. The rubber reel pads were removed. These screws were removed in order to remove the reel tables. Each hub had 3 metal shims, which were removed from the hub adapter. 8 screws were removed from the front panel. Then the tape tensioner was removed. It was held in place with 1 knurled screw. The pinch roller was removed by pulling it straight out. The slotted shaft held it in place. Finally, the aluminum trim piece around the capstan was removed, allowing the brushed aluminum front cover to be removed. 6 additional screws were removed in order to free the chassis from the wooden case. Compressed air was used to blow years of dust from both the wooden case, the front, and back of the chassis. I used my office chair to move around heavy things like the chassis in order to save my back. Here were the remains of one of the rubber belts. Reel brake repair. The reel felt brake pads had broken loose and were inverted 180 degrees from where they were supposed to be mounted. Here were the felt brake pads removed from the chassis. In order to glue the reel felt brake pads back in place, the reel hubs were removed. Each reel hub was held in place to the motor shaft with 2 set screws. The reel felt brake pads were supposed to be adhered to these copper bands. They were re-glued to the copper bands using flexible E6000 glue. The reel hubs were left removed, as the right one would have to be removed again for belt installation. Belt insulation. The counter belt was still intact, but the capstan belt had disintegrated. The counter belt was easily replaced with the right hub removed. This was also a good time to lubricate the front reel motor bearing. On both reel motors, I used Labelle 107 plastic-friendly oil intended for model trains. Both the left and right wheel hubs were then reattached to their respective shaft using the 2 set screws. Pivot joints were oiled here, 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 and here. The capstan belt connects between these 2 pulleys. It can be replaced without removing the capstan by removing 1 screw from this bracket on the back side of the chassis, and then sliding it down. The capstan belt can then be slid around the capstan pulley from the back side. Then the bracket can be slid up and fastened back in place with the required screw. The newly installed capstan belt. High voltage electrolytic capacitor replacement. The 1966 TEAC A1500W reel-to-reel tape recorder employs several high voltage electrolytic capacitors. After 59 years, electrolytic capacitors lose their capacity as their electrolyte dries up. It is important to replace electrolytic capacitors with the same capacity and same or higher working voltage. I did not need to observe polarity as I replaced the high voltage electrolytic capacitors with non-polarized Mylar ones. Here is the much smaller Mylar capacitor soldered in place. These high-voltage electrolytic capacitors were used mainly to suppress counter-EMF or electromotive force caused by the relay coils employed in this reel-to-reel tape recorder. This reel-to-reel tape recorder employed two multi-section capacitors. They were not replaced as new ones would be difficult to source. Low-voltage electrolytic capacitor replacement. The main printed circuit board employed many low-voltage electrolytic capacitors. 3 connectors were removed, then 5 screws, and 2 wires must be desoldered in order to access the component side of the main printed circuit board. The main printed circuit board could then be flipped up in order to access the solder side. In total, 47 low-voltage electrolytic capacitors were replaced on the main printed circuit board. These 4 trimmer potentiometers had to be desoldered from the main printed circuit board in order to access the solder side for low-voltage electrolytic capacitor replacement, then resoldered in place after. It was important to solder each trimmer in the same position of which it was removed, as each had its own resistance setting. I carefully cleaned the component side of the main printed circuit board using Q-tips moistened with Windex, my go-to cleaner. Here was the end result of cleaning. You could actually see the true color of the phenolic main printed circuit board. There was also a 0.05 microfarad 400 volt electrolytic capacitor on the solder side of the main printed circuit board that I missed. It was replaced with a non-polarized Mylar capacitor of the same capacitance and higher working voltage. The 2 wires were then resoldered in place to the main printed circuit board. 5 screws were then reinstalled. Unfortunately, the nuts on the other side were not captive. It was a tedious process reinstalling them. Finally, the 3 connectors were reinstalled. Here were all the low and high voltage electrolytic capacitors I replaced during this restoration project. Potentiometer and switch cleaning. The input and output potentiometers were accessed from the bottom of the chassis for cleaning. I used Deoxit D5 to clean their contacts and resistive traces. The power and tape monitor switch contacts were cleaned with Deoxit D5 contact cleaner as well. The record selector switches were cleaned with Deoxit D5. Finally, all relay contacts were cleaned with Deoxit D5. The TEAC A1500W's chassis was then moved back to its upright position. Electro-mechanical repair. The grease on the pinch roller slide assembly had turned into a tar-like substance with age. This prevented it from moving freely. I used Deoxit D5 as a degreaser in order to remove the old grease from the pinch roller slide assembly. With a little lubrication using Labelle 107 oil at the pivot points and slide, the pinch roller freely moved back into its resting position. The pinch roller's rubber tire had hardened with age. I ordered a replacement pinch roller rubber tire from eBay. The C-clip was removed in order to remove the pinch roller wheel from the shaft. A snap ring clip was also removed using my snap ring pliers I had from my shade tree mechanic days. The pinch roller's rubber tire must have been molded onto the wheel as it was very difficult to remove. I used a razor blade to remove as much of the rubber tire as possible from the rim. Then I affixed the wheel onto a drill bit, using electrical tape. 240 grit sandpaper was used to remove the remaining rubber remnants from the rim while being rotated by an electric drill. Both the front and the back of the rim was cleaned up with sandpaper as well. All metal pinch roller parts were cleaned with denatured alcohol. Then the new rubber tire was installed onto the pinch roller wheel. It slid in place. The snap ring clip was installed using my snap ring pliers. The pinch roller shaft was lubricated with Labelle 107 oil and installed onto the shaft. The washer was installed. Then the C-clip was pressed into the shaft groove. The pinch roller was then installed back into the pinch roller slide assembly. The compliance arm assembly would not move as well due to the old grease turning into a tar-like substance. It had to be disassembled for cleaning and lubrication. A single screw on the back side of the chassis held the compliance arm assembly in place. The removed compliance arm assembly. The arm stopper was bent away from the shaft, in order to free all compliance arm assembly parts. All parts were cleaned with denatured alcohol. Label 106 PTFE grease was used to lubricate the arm shaft. Then the arm holder was installed onto it. The arm spring and arm stopper were then reinstalled. The arm stopper was then bent back into place, securing the arm holder. The compliance arm assembly was then reinstalled onto the chassis, secured in place with a single screw. During low voltage electrolytic capacitor replacement, I missed these two axle 220 microfarad 50 volt electrolytic capacitors on the power supply printed circuit board. 3 screws held this printed circuit board in place and had to be removed. They were replaced with 2 modern radio electrolytic capacitors of the same capacity and working voltage on the foil side of the printed circuit board. Look how small the modern equivalents are compared to the 1960s originals. A dab of E6000 adhesive was placed under each inverted capacitor to relieve the stress on the component's leads. The adhesive was allowed to dry for a couple hours, before the power supply printed circuit board was fastened back in place with 3 screws. I also took a moment to dust off these 2 large voltage divider resistors using a Q-tip moistened with Windex. Chassis testing. The power cord and audio cables were connected to my 1966 TEAC A1500W reel-to-reel tape recorder, and the tape was threaded between the reels. The other side of the audio cables were connected to my vintage Magnavox stereo record player console, which was set to tape input. The rubber tape reel holders are not as flexible as they were in 1966. I had to add a piece of 18 gauge insulated solid wire to each tape holder in order to get them to stay in place. I discovered that the pinch roller mechanism still had a slight jam and there was no audio from channel output B. In addition, I noticed that the no-name brand aluminum take-up reel that I purchased from Amazon was clearly bent. I replaced it with a genuine Scotch take-up reel that had a much better alignment. I had to bring out my early 1990s Tektronix 2336 dual trace oscilloscope in order to troubleshoot the no audio from channel output B. With my 1966 TEAC A1500W reel-to-reel tape recorder chassis set on its back, using my oscilloscope I was able to trace the channel output B signal from the foil side of the main printed circuit board. I determined that the tape monitor's switch contacts were not making good contact, causing the channel output B audio problem. Hitting the tape monitor's switch contacts with another round of Deoxit D5 contact cleaner resolved the problem. Audio on both stereo channels were restored. Chassis installation. The wooden case, faceplate, back cover, and head housing were cleaned using my go-to cleaner, Windex. Then the wooden cabinet and back cover were treated to a coat of lemon pledge. The chassis was partially assembled for testing. The following had to be removed before chassis installation into the wooden cabinet: tape reels, audio cables and power cord, reel pads and reel tables, compliance arm, and pinch roller. The chassis was then ready for installation into the wooden cabinet. Whoops, I forgot to remove the fuse cover and jumper plug. The chassis will not slide into the cabinet when these are installed. The chassis was then slid into the wooden cabinet. 6 screws held the chassis in place. 2 screws were also installed on top. The faceplate was then installed. It was held in place with 8 screws. Once again, the reel tables with shims, reel tables covers, compliance arm, aluminum trim piece, pinch roller, and finally the head housing was installed. The wooden cabinet was then turned around so the back cover could be installed with 8 screws. It was then time to install the fuse cover and jumper plug, then audio cables, and power cable. Finally, an audio tape was then installed. Conclusion. This was the first reel-to-reel tape recorder I have ever restored. The most difficult part of this restoration was getting the electromechanicals like the pinch roller, compliance arm, and belt drive working correctly. At a whopping 42 pounds, I was not able to lift my TEAC A1500W reel-to-reel into my stereo rack. Instead, it will sit on my project table and be connected to the tape input of my vintage Magnavox stereo record player console. I completely forgot about the clear plexiglass cover that came with my TEAC A1500W reel-to-reel tape recorder. It was thoroughly cleaned with Windex. One of the corner braces of the clear plexiglass cover had broken free. It was fixed with a couple drops of super glue. Please like this post and subscribe to Radio Boat Anchor so that you're alerted to my future posts. Thank you.